I'd now like to look at some exam questions that are comparing acidities and comparing basicities. Let's talk about this one here, and you see we've got these two compounds A and B. I think if we're comparing acidities, the first thing we should do is to write out what the anions look like when they release H+. And what we do is we take the H plus off the oxygen here on the phenol, and we'll do the same thing to the other one. Alright, so that's what the anions look like. Now we can investigate what's going on here. Now it says which acid has the higher pKa. Now we know we're dealing with acids. We want to deal with acids because we've got these H pluses here being formed. And it says which one has the higher pKa. Well, higher pKa means less acidic. So I know that that's the first part. And now we've got to figure out what kind of groups we have. And the one with the, if we look at what these are going to do, we can see that the activating group will be pushing electron density into the ring, while the deactivating group will be pulling electron density out of the ring. This one is going to destabilize, and that's going to make things less acidic, and make this one less acidic. And this one is going to stabilize the anion and make this compound more acidic. Now, since we're looking for the one that's least acidic, we're looking for the one that destabilizes the anion. So this is going to destabilize. And the one that has the activating group is doing the destabilizing. And this one is A, and this one is B. So the answer is compound A. So compound A has an activating group that destabilizes the anion of the conjugate base. This is the conjugate base here, and it makes this compound, which is compound A, less acidic. Alright, let's look at examples that relate to this compound here. Now we're looking at basicity, and if we're talking about basicity, then we're looking at the ability for these compounds to take on H+. So I will show those two examples and how they take on H+. Alright, so now the H plus will go on to the nitrogen from the amine group. And we know we got the H plus on this side because we're talking about basicity, and we know it's basicity because it's pKb. Also, when you see this kind of question, which compound has a conjugate acid with the higher pKa, then we know we're dealing about bases as well, but that's going to be on the same information too. And again, the H plus goes on the amine part here. Alright, so now we're looking at the first one. It says higher pKb. Now higher pKb means the one that is the weaker base. So we're looking at the less basic here. If we were looking for lower pKb, that would be the more basic one. Alright, so looking at the wording here, compound A, compound B has an activating or deactivating group that adds or subtracts electron density to or from the N-lone pair, making the compound less basic. Well, if we're talking about the compound being less basic, then we've got to look at something that's going to take electrons away from the NH2. Alright, so we're looking down here, we see the NO2 is going to be a deactivating group, so it's going to pull electrons out of the ring, while this N-dimethyl amine group is going to be pushing electrons, it's going to be pushing electrons into the ring. Let's do it on the one we're talking about. Alright. So what we're looking for here is one that's going to be pulling electrons away from the nitrogen to make it less basic. Because if we can pull electrons away from this, then that's going to make it less able to take the H plus and form this conjugate acid. So this is the one that's going to be the least basic one, because it's going to be pulling electrons away from this nitrogen. So we're going to say that this one will subtract electron density to make it less basic, and it has a deactivating group, and we are talking about compound A. Alright, so that's how we handle that one. Compound A has a deactivating group, that's the nitro group, which subtracts electron density from the N-lone pair, making the compound less basic, so it's pulling electrons away from the N, making it less basic. Okay, looking at the same compounds again, which compound has the conjugate acid with the higher pKa? So we've got the conjugate acids over here, we've already drawn them out. Now we're going to look at how those are affected. And we're looking here for the higher pKa, that's the one that is less acidic. And we're looking at the wording here, compound A, compound B has an activating or deactivating group that adds or subtracts electron density to or from the N-lone pair, making the conjugate acid more or less acidic. So we're looking for the less acidic one here. And out of these two, we've got to look at the effect of the group on each of these. And what I want you to see is this: if you've got a nitro group and it's taking electron density away here, then what's going to happen is that it is going to make this cation here less stable, which means that it's going to want to get rid of H+, which is going to make this one more acidic. In this case, what's going to happen is the nitrogen is going to donate electrons into the ring and stabilize this cation. And this cation then will be less willing to give up H+. So this particular conjugate acid is going to be less acidic. And the compound we're talking about here is compound B. And compound B has an activating group, which is adding electron density to the lone pair. And this is going to make the conjugate acid less acidic.